Hi everyone, welcome again to your course, Geology for Engineers. So today we will tackle the first part of your module number 1. This is your instructor, Engineer Janaika T. Azarias. So as mentioned, the first part of your module 1 is Engineering Geology, and this presentation is prepared by yours truly and another engineer, Jenica Dagdag. So first, let's define our terms, the terms that we will be using throughout the course. So first is what is engineering. So as you can see here, it's actually an art or science of making practical application of knowledge based on sciences, physics, or chemistry, and to make use of this in the construction of engines, bridges, mines, ships, plants, chemical plants, etc. So this definition is taken from your dictionary.com. So we have a picture here that depicts just a few of the things that when you see it, you should already think of engineering or engineers. So next, let's define geology. So when we talk about geology, this is actually a study of the earth, the materials of which it is being made from, the structure of those materials, and of course the processes that takes place with the structure of those materials. So you have here, he may be a uh, geodetical engineer, or he may be a geologist, or any other fields related to geology. And when we combine the two terms together, we get engineering geology, which is defined as the application of the geology to the engineering study for, of course, the purpose of the geological factors such as your location, design, construction, operation, and maintenance of engineering works that are recognized and accounted for. So nakikita niyo yan, 'di ba? Parang sina-survey po yung land area. So we have actually a lot of branches of geology, but these are the things that is actually related to engineering. You have your chronology, tectonics, natural resources, sedimentology, topography, astrogeology. So these are the things that's related to engineering, and we will tackle each one of them. So let's start with chronology. When you actually think about chronology, di ba, it's kung yung kumbaga, yung in Tagalog or in Filipino, yung pagkakasunod-sunod, di ba? Chronological order. So as you can see here in the picture, you have the order of the or order of how the earth was formed starting from 4.6 billion years ago, terming it as the Archean era up to your Cenozoic era, wherein you have the current our current era. So studying the layers of rocks, or when we say chronology, it's actually defined as studying the layers of rock as it relates to geological time. So let me just have a pen here. So it's the study of the layers of rock related to geological time. So we have a few terms that you would need to be familiar with. Kumbaga kasi itong engineering geology that we are trying then to teach you would actually be an introduction of the higher engineering courses that you will be taking. So it's only a must that you be familiar with certain terms that you would be encountering later on. So first term is you have your geochronology. And as you can see here, it is a field of scientific investigation concerned with determining the age and history of Earth's rock and how it was assembled. And the second is your paleoseismology. So paleoseismology is the study of prehistoric earthquakes as preserved in the geologic earthquakes. Because when earthquake happens, of course, the structure of the earth changes, resulting to resulting to how our kumbaga, resulting to changes in the land itself. And paleoseismology is the study of that. And you also have your magnetostratigraphy, and this refers to the description, correlation, and dating of rock sequences by means of magnetic parameters. You also have your paleontology, the study of ancient life or fossils or preserved fossils. And you also have your stratigraphy. It's a scientific discipline concerned with the description of rock successions and their interpretation in terms of a general time scale. You also have your micropaleontology, which is a branch of your paleontology dealing with fossils that, owing to their very small size, that's why they have to be studied inside a microscope or in a microscopic level. So next is your tectonics. When we say tectonics, this is applying the principle of plate tectonics to your geology. And under this, you have your volcanology. So this is how and where volcanoes and related phenomena like your lava or magma erupt and form from your past to your present. You have your seismology, how seismic waves travel through and around the earth, forming, of course, your earthquakes. And you also have your neotectonics, concerning the study of horizontal and vertical crustal movements that have occurred in geologically recent past and which may be ongoing today. Neotectonics. You also have your tectonophysics, which is a branch of geophysics, and it is the study of physical processes that underlie under tectonic deformation. And you also have your seismotectonics, which studies the relationship between your earthquakes, faults, and tectonic processes. This incorporates information from various disciplines, such as the study of such as that of seismology, geodesy, and geology. Now let's go to your natural resources. So of course you can see a picture of some of our natural resources. That's your sun, forest, rock, minerals, animals, air, oil, water, and of course your soil. So when we say natural resources under geology, this is actually the study of your rocks, terrain, and minerals. And under this, we will be dealing with the following terms. You have your petrology. This is how types of rocks, diba? You should be familiar with this. Your igneous, metamorphic, sedimentary is formed in their specific environment. You also have your mineralogy, how the chemical, this is deals with the chemical and crystalline structures of your minerals. You have your gemology. This is how your natural and artificial gems are identified and evaluated. Your crystallography, how atoms are arranged and bonded in crystalline solids. So I believe crystallography is one of the things that you have already, you should have studied in your chemistry for engineers. I think it's part of your midterms. So it's all about atoms, how they are actually packed. So I believe you should have known that or you should have studied that in your chemistry. And you also have your soil science. This is how soils relate as natural resource, including their formation factors, classification, physical, chemical, and fertility properties. And also under natural resources, you have your pedology. This is how soils are classified based on their biological, physical, and chemical properties. Your edaphology, how soil influences plant growth and other living things. You have your agronomy or your agrology, how the field of agriculture involves science such as crop production, biotechnology, and soil science. You also have your hydrogeology, how your ground or your groundwater rather is transported and distributed to your soil, your rock, or typically in the earth's crust. You also have your pomology, or how your fruits grow and are cultivated. So next is your sedimentology. So when we say sedimentology, this is understanding erosion, movement, and deposition of your sediments. And under this, you have your glaciology. This is typically the study of snow and ice and their physical properties. More specifically, glacial glaciologists analyze the formation and movement of different types of glaciers. And you also have your hydrogeology, the science of currents, distribution, and movement of water below the Earth's surface. And of course, your lithology uh, refers to the general characteristics of your sediments, rocks, and rock types present in a stratigraphic division of the Earth. And you also have your superficial geology, which refers to the study of landforms and the unconsolidated sediments that lie beneath them. Your bedrock geology, which deals with the changes in the Earth's crust over time. Yeah, over time. Those are the terms that you would need to be familiar with under sedimentology. And next is your topography. So when we say topography, this deals with the mapping terrain and processes that act on it. And under topography, you have different types of sciences that you have to deal with. You have your orography, which is a physical branch of geography that deals with your mountains. You have your geomorphology, the study of landforms, their processes, forms, and sediments at the surface of the earth and sometimes on other planets. You have your hypsometry, describes the distribution of elevation of land with respect to the sea level within an area of interest, with positive values being above the sea level and of course your negative values below the sea level. And of course your geography, the study of places and the relationship of people with their environments. And you also have your astrogeology. So when we say astrogeology, of course, it's the geology concerned with bodies in the solar system. Some of which are your asteroids and the planets and their moons. So those are just some of the terms that you would be encountering throughout your higher kumbaga engineering courses related to geology. So these are the references used for this particular presentation, and I will we will be dealing with the second part of your module number 1 in a while. Thank you for listening, class. Please stay home, stay healthy, and stay safe. Goodbye, everyone.